Hi, my name is Jinglan Wang. This is my student ID card, and my Z number is 5630954. Today, I will walk you through my experiment for Physics 1160 about understanding the solar system. So let's begin. When we look at the solar system, one question stands out. How do planets orbit Sun so predictably? Kepler's law can answer this question. Kepler's first law shows that planetary orbits are not perfect circles, they are ellipses, with the Sun set at one focus. Through Kepler's second law, we discover that planets speed up when it's closer to the Sun, sweeping equal area in equal time. And Kepler's third law found a mathematical relationship. The square of a planet's orbital period is proportional to a cube of its average distance from the Sun. Now let's solve question 9. Does the planet move as the Moon orbits? Yes, the planet does move slightly as the Moon orbits. The Moon pulls on the planet just as the planet pulls on the Moon. However, since the planet's mass is typically much larger than the Moon's, the planet's motion is very small and may appear nearly stationary in the simulation. In question 1, the center of mass is located extremely close to the Sun's center because the Sun's mass dominates the system. In question 4, if the planet's mass is significantly increased, the center of mass shifts slightly towards the planet but remains inside the Sun because the Sun still dominates mass. In question 7, if the star's mass is reduced, the center of mass moves into the space between the star and the planet, closer to the more massive object. In the planet and the Moon system, the Moon's mass is much smaller than the planet's, so the center of mass lies very close to the planet's center. But in the Sun and the planet system, even if the planet's mass is large, the Sun's enormous mass ensures that the center of mass remains near or inside the Sun. For question 11, we know that the distance between Earth and the Sun is 1 AU. When the grid lines were opened, we found that the distance were exactly 2 markings, so each marking is 0.5 AU. This table records the time it takes each planet to complete one orbit and this orbital distance. To verify Kepler's third law, we need to calculate the ratio of a planet's orbital period squared to the cube of its average distance from the Sun. After calculation, we found that these ratios are similar, so it does follow Kepler's third law. Let's move to question 15. In the solar system, Mercury has the fastest orbital speed. The orbital speed of Neptune is the lowest in the solar system. According to Newton's law of universal gravitation and the formula for circular motion, the orbital radius of a planet is inversely proportional to its speed, which means the smaller the orbital radius of the planet, the faster its speed. Mercury is the planet with the smallest orbital radius in the solar system, about 0.39 AU. Therefore, its orbital speed is the fastest. The planet with the largest orbital radius in the solar system is Neptune, whose orbital radius is about 30 AU, so its orbital speed is lowest. In this experiment, I learned Kepler's 3 laws. Among them, Kepler's second law made me understand the planets move faster near the Sun and slower further away. In the simulation, the Sun's dominance in mass ensures that the center of mass is closer to its core. However, in the planet and the Moon system, the center of mass is closer to the planet. I also learned how to calculate based on Newton's law of universal gravitation and the formula of circular motion. The orbital radius of a planet is inversely proportional to its speed. Mercury is the planet with the fastest orbital speed in the solar system, and Neptune is the lowest. This is my reference. Thank you for watching.